Hello, welcome to the last question, which is the AP question for Quideo number 2. This one tells us about windmills and how they generate electricity and depending on the miles per hour of the wind velocity. So question A asks us to use this computer output and to determine the equation of the least squares regression line. So right here, I actually have the equation, 1.137 plus 0.240x. I got that from the constant of the coefficient of 0.137 for the constant, which would just be the y-intercept, and then for the wind velocity, which is the slope, it would be 0.240, and I put that as a slope. So x would be wind velocity, since this is dealing with the slope for the wind velocity, and y would equal the predicted electrical output in amps. B then asks us to see how much more electricity the windmill would produce on a day where there's 25 miles per hour compared to 15 miles per hour. So right here, I use the regression line. I brought it down here. So I plugged in 25 miles per hour, and I got 6.137. And then I plugged in 15 miles per hour, and I got 3.737. So since it's asking us to see how much more it produces, I just subtracted 6.137 from 3.737, and that will give us 2.4 amps more. So when it's 25 miles per hour, it will produce 2.4 amps more than if it was 15 miles per hour. Then C asks us what proportion of the variation in electricity production is explained by its linear relationship. So if we look back up to this calculator output that they gave us, they actually gave it to us right here, r squared. R is just explaining if the linear regression line is a good fit. R squared explains how much of that data that regression line explains. So if you look over here, r squared is actually 0.837. So that means that the regression line explains about 87% of the data, which is a very high percentage.